Number 13, simplify. Simplify just means we need to get rid of the i's in the root and the denominator. Easiest way to do that is to start by reducing, so that reduces to 4 over 1. So if we have 4 over I root 5, okay, it makes it so we're going to have to multiply by a lot smaller numbers, which is just a little bit easier. So multiply by I root 5. Remember, this is called rationalizing the denominator. If you multiply through, we got 4I root 5 over I times I is an I squared. Root 5 times root 5 gives you a 5. I squared becomes negative 1. Okay, it doesn't matter if you write the negative with the top or the bottom. Either way, it's 4I root 5 over negative 5. And you could have written the negative with the top. Either way, it doesn't really matter. Number 14, we're going to distribute and then combine like terms. So distribute that negative, distribute the 2I. Okay, so it's going to be big old combine like terms. So 2 plus 4I minus 15, negative 3 and negative 8 gives you plus 24I. 2I plus times 4 gives you plus 8I. And then 2I times 5I gives you plus 10I squared. Okay, the I squared becomes a negative 1 multiplied, so that's negative 10. So if we add together all the real parts first, all the whole numbers, 2 minus 15, that's negative 13, minus another 10 is negative 23. 4I plus 24I, that's 28I, plus another 8 is plus 36I. Okay, for number 15, to get rid of this, you multiply by the conjugate. Conjugate is 9 plus I. Remember, we're only changing the middle sign. So distribute in the numerator, 18 plus 2I. FOIL in the denominator, 81 plus 9I minus 9I minus I squared. The 9i's cancel each other out. Negative I squared becomes a plus 1. So we have 18 plus 2I over 81 plus 1 is 82. And then reduce, okay? If you reduce this, I know 2 goes into both of them, so that's 9 over 41 plus I over 41. Leave them separated. It's a little bit easier to read the multiple choice answers that way. Okay, so both separated. For number 16, combine. Okay, these are the same denominator, so you can add them together. So that gives you 12 over 3I. Okay, just combine the numbers on top. This reduces to leave you 4 over I. Then to get rid of the I in the denominator, multiply it away. That leaves us with 4I over I squared. I squared becomes a negative 1, and we don't want to write that like that, so you just move the negative to the top, and we got negative 4I. Number 17, if you solve for x, okay, this is already squared, so to get rid of that square, we want to root both sides, make sure you put in plus or minus. X squared minus 6x minus 4 equals plus or minus root 144 is 12. Let's split these up. So x squared minus 6x minus 4 equals 12, and x squared minus 6x minus 4 equals negative 12. Before I can decide what I want to do, it's easiest to get everything on one side. So we want to try to factor if we can. Okay, try to factor if you can. So here, this is going to leave us with x squared minus 6x minus 16 equals 0. That is factorable. Okay, x minus 8 and x plus 2. Break those apart. Positive 8, negative 2 is answers. But you're not done. I have to do the same thing on this side. Okay, do the same thing on this side. Leaves you with x squared minus 6x plus 8 equals 0. That is also factorable. So x minus 2 times x minus 4 equals 0. Break those apart. Positive 2, positive 4. Does not matter which order you write these in. Okay, doesn't have to be in any particular order. Okay, last page for number 18. What are the solutions to the equation? Okay, first thing you want to do is to get this all in one side to decide if I can factor it. Okay, so start by adding 5 to both sides. Leaves you with x squared minus 8x plus 9 equals 0. Okay, this is not factorable. Okay, there's nothing that will multiply to 9 and add to negative 8. Doesn't work that way. So, a couple different options here. You could complete the square, or you could use quadratic formula. Either one would be fine. Okay, I'm going to complete the square because I like it a little bit better. So, subtract 9 from both sides. So, we'll move it over here. X squared minus 8x equals negative 9. So, I've created that space. Okay, so fill in the blank. Take that middle number, divide by 2 and square it. Now I show this work so that it's easy to be able to find my binomial squared. So I'm going to add 16 to both sides. Okay, if you add 16 to both sides, this is x minus 4 squared. And look, you could either factor this or it comes straight from there. Okay, then it's equal to negative 9 plus 16 gives you 7. Root both sides. Put in a plus or minus. X minus 4 equals plus or minus root 7. And then to get this by itself, x equals 4 plus or minus root 7. You can leave it all together. So 4 plus or minus square root of 7. Now, this one specifically says solve by completing the square, so you have to. Okay, if it asks you to do something a specific way, I want to see it done that way. No quadratic formula, no factoring, none of that. Okay, so start by creating your space. So move over the 11 and have an open space to fill. So we take the middle number, divide it by 2 and square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4, so we're going to add 4 to both sides. Factor that is x minus 2 quantity squared equals negative 7. Square root both sides. Make sure you put in your plus or minus. X minus 2 equals plus or minus. Take out an I, left behind with a root 7. To get x by itself, add 2 to both sides. So x equals 2 plus or minus I root 7. 2 plus or minus I root 7. Now, for number 20, it specifically says use the quadratic formula. So you have to use the quadratic formula. It has to be equal to 0 before you can do that. So if you label your ABCs, A is 1, B is 3, C is 1. If you need to, actually write out the quadratic formula. Remember, it's x equals negative b plus or minus radical b squared minus 4ac over 2a. Sing the song if you have to. Okay, so negative times 3 plus or minus root 3 squared minus 4 times a is 1, c is 1 over 2 times 1. Negative 3 plus or minus root 9 minus 4 over 2 becomes negative 3 plus or minus root 5 over 2. Okay, negative 3 plus or minus square root of 5 over 2. Number 21, solve. Doesn't matter how you solve this, but it's probably the easiest just to start by dividing by negative 2. We divide by negative 2. Quantity x minus 5 squared equals negative 6. This is a square, so I can root both sides. Okay, if I root both sides, make sure you put in a plus or minus. X minus 5 equals plus or minus I root 6. Add 5 to both sides. X equals 5 plus or minus I root 6. For number 22, okay, couple different ways you could do this. Doesn't matter which one, okay. I'm going to choose to move this to the other side. So 3x squared equals negative 25. Okay, divide both sides by 3. I want to root both sides to get that x by itself. So x squared equals negative 25 over 3. Square root both sides. Okay, if you root both sides, we get x equals plus or minus. Remember, this is root negative 25. That's the same thing as root negative 25 over root 3. That simplifies to be plus or minus. You can take out a 5i over root 3. Cannot have a radical left in the denominator, so multiply by root 3 to rationalize that denominator. So we end up with plus or minus 5i root 3 over a whole 3. And then last one, simplify. Multiply the two numbers together, we get negative 35. Add the I exponents together, so that's I to the 7th. Okay, if you write out your I chart, remember, I1, negatives sandwiched in between. So really this is negative 35 multiplied by I to the 7th is 1, 2, 3, 4, 5, 6, 7 multiplied by negative I. Those are multiplied together, 35i. The negatives cancel each other out, but that is not a binomial. Okay, it's just a monomial. Multiply them together. That's it.